what if we have to add another node to this linked list? Let's create a function called push. It will do the same thing as array.push. So we will create a function push. It will accept a value. The first thing it will do is create a new node with the given value, and then it will push this new node to the end of our list by setting tail.next is equals to new node. Now this new node is the last node of this list. So let's set the tail is equals to the new node. Okay, let's cover an edge case now. What if we want to push this new node into a linked list that does not have any nodes yet? Here we will have the head and the tail point to it. Okay, now tell me one thing. How do we know that our linked list is empty? We will check if we don't have this dot head. This means that we don't have any node in our linked list, because if there had been a single node, then it would have been the first item and it would have been the head. So this is our edge case scenario, and now let's put our old code as else, that is when edge case scenario of linked list with 0 nodes does not apply. And now as we have added a new node to this linked list, let's increase its length by 1. So this is our entire linked list code, and as you can see we have a linked list with a node A, and we have pushed B, C and D into this linked list, and now our linked list looks like this. And one last thing I wanna add is that let's return this in our push function. So now when we push something in our linked list, it not only adds a new node and increases its length by 1, but it also returns the linked list in a console or the variable you might save it in. Creating a new node, increasing length variable, and returning this are O of 1 operations. If linked list is empty, this code block will run and it's O of 1. If linked list has some nodes, this block will run and it's also O of 1. So the final big O of push method is O of 1. That's amazing fast. Let's create a pop method.